Okay, so the first reason we use a variable is to represent something we don't know. The second way we use variables is when our answer changes. Okay, so let me give you an example. All right, Louisa works at McDonald's and she gets paid $8 an hour. How much does Louisa make? Well, she makes $8 an hour, but how much did she make last week? Well, it depends, right? Doesn't it depend? What does it depend on? Well, it depends on how much she worked. Yeah. So we could say we have two things that change, right? We have the amount of money that she makes. That's what I want to know. That's my interest. I want to know how much she made. And we have the thing it depends on. We have the amount she works. So the more she works, the more she gets paid. The less she works, the less she gets paid. So we have this relationship between how much she works and how much she gets paid. So we call this relationship well, this happens to be a linear relationship, and I'll explain why in a later video why that's called a linear relationship. But just for now, know that the more she works, the more she gets paid. As one goes up, the other one goes up too. So I can make let's make a little table here. So one tables, we love tables in math, just because it keeps everything organized. You could make a list, but I like tables because again, it shows us everything nice and organized. So again, I'm going to have let's see, I'm going to call, well, let's put the hours she works. Okay, hours she works on top and how much she gets paid on the bottom. So if she works 1 hour, she'll get paid $8. If she works 2 hours, she'll pay $16. If she works 3 hours, she'll get paid $24. And if she works, well, we'll stop right there. Okay. So every hour she makes $8. So you can see my hours are going up by one, my money is going up by $8 every time. Um, Here's the thing, okay? I could describe this relationship. I could continue making this table as long as I want. I could go on forever and ever and ever, telling you every single hour, right? If she worked 1,212 hours, I could figure that out. Okay? And but maybe I don't want to. That sounds like a lot of work. I don't want to make a table forever. So it'd be nicer if I could just give a relationship between the two. If I could just say, look, take whatever number of hours it is and do this to it. Okay? So let's look for a pattern here. What is the relationship between the number of hours she works and the amount she gets paid? How do we get from 1 to 8, or from 2 to 16, or from 3 to 24? And hopefully you see a pattern here. What we're doing here is for every hour, we're going to multiply that by 8 to get how much we get paid. So 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24. Okay? So no matter what, now I can just say, instead of having to make out the table, I can just say, look, you want to know how much you get paid? Keep track of your time, however many hours you got paid, multiply that by 8, that's your paycheck. Right? That'd be a lot easier than having to print out this whole table and make, okay, go look it up. Go look up how many hours you worked, that'll tell you your pay. Right? It'd just be much easier. I can say, multiply by 8. Okay? So again, I can use a variable to represent the number of hours I worked. Okay, instead of having to look it up every single number, I could just say, well, let's say we worked, again, I'm going to use X. Let's say I worked X hours. Okay. That can change. One week, maybe X is I worked 20 hours. The next week, it could change. The next week, I could have worked 25 hours. Week after that, maybe I worked 10 hours, right? Depends. I mean, it just changes. So quantities that change, quantities that vary, that's what vary means. Vary means to change. We call variables. Okay, that's why that word variable exists. That's why it's called a variable. Is because a variable describes something that can vary. So if you think about all the different kinds of numbers we use in everyday life, most of the numbers really we use can change. Okay, my weight can change. My age definitely changes. The price of food changes. The price of gas changes. The number of students in my class changes. So some students move in, some students move away. Most everyday life changes at some point, right? Most everything we have changes. And so really, most everything we deal with in an everyday life is a variable. Now, it doesn't always work out as nice and even as this. You multiply by 8, you'll get your answer. But most everything we deal with is actually a variable. There's very few things that are not variable. Okay? Um, And in this case, right, we literally talked about the pattern. If I worked for X hours, how am I going to find out how much I get paid? Well, just take my hours, multiply by 8. So I could write down, just like we did in the last video, I could write down X times 8. And that's how much I got paid, right? You tell me how much you work, how many hours, I multiply by 8, that's your paycheck, right? You tell me you worked X hours, okay, here's your paycheck, X times 8. Again, I said from the last video, I said again, usually don't write X times 8, they like to put the number in front, and they like to put in, to leave out any kind of time sign, so there it is, 8x. It's the same thing, X times 8, 8 times X, doesn't matter. Okay. So that's my pattern. Okay. Now, think about this. Not only is the amount of hours, the number of hours you work, does that change it from week to week, but your paycheck changes. So your paycheck is also a variable. Some weeks I get paid $200. Some weeks I get paid $100, right? Depending on how often I work. So that also is a variable. The number of, we'll call that number of hours you work X. This one's also a variable. But here's the thing, we can't call it X because X was already taken. If I called this X, that'd be really confusing, right? You would have something like X equals 8 times X, and that just sounds really strange. Don't do that, right? If you have different things in the same problem, call it by a different letter. So usually what they'll do is they'll use Y. Again, it doesn't matter. You could call that one H, you could call that one D for dollars, doesn't matter. H for hours, D for dollar, doesn't matter. Oftentimes they'll use T for time. Um, doesn't really matter. You could use a smiley face, you could use a box, you could use a check mark, you could use a question mark, you could use anything you want. But we usually use X and Y just because that's what people have been doing for hundreds of years and we'll stick with it. In this case, we have two variables, X and Y, and they have a relationship, right? Y is always going to be 8 times as big as X because that's the way I get paid. That's my paycheck. I get $8 per hour. I could also write this, then I could put an equation that relates X and Y. So an equation is just a math sentence with the word is in some place, or related to two things. So if I wrote it in English, I could say, your paycheck is 8 times the number of hours you worked. Okay, makes sense. You work 1 hour, you get $8. You work 2 hours, your paycheck's $16. But this is so long, and in math, I don't know. We don't like to write so much. We're kind of lazy. We like to put equations. So instead of your paycheck, I'm putting Y because that represents your paycheck. The money you take home, your money, Y. And instead of is, I'm going to put the equal sign. Equal sign just means is, right? If I say, I am Mr. Baker, that just means I and Mr. Baker are equal. We're equivalent. We're the same thing. Right? Paycheck is 8 times the number of hours you worked. And again, we called the number of hours you worked, we called it X. So there's my equation. There's it. And I can get rid of that dot number in the middle. I can get rid of that. So this little equation right here is exactly the same thing as all these words right here. As long as I represent your paycheck with Y and the number of hours you worked with X. Okay? That's it. And usually in a word problem, they'll say that. They'll come right out and say, let X be the number of hours you worked. Let Y represent your paycheck. They'll say that right in the problem. So there's my equation for this problem. Okay. Now let's continue with this problem. Actually, I kind of like this problem with $8 per hour. Sometimes a letter can be both a variable and an unknown. A variable representing something that's changing, something that's varying, and also an unknown. Okay. So let me give you this. Right here we have two variables, but if I tell you what one of the numbers is, suddenly it's not a variable anymore. Right? So let me give you an example. I'm going to tell you right now that Louisa worked 10 hours last week. Okay? So suddenly, that's not a variable anymore. I mean, it's still, Yeah, her depends, but I'm telling you, she worked 10 hours. That's not unknown anymore. She worked 10 hours. So I know that X is 10 in this case. Now, in other weeks, it might be something different. She might work 20, but in this week, she worked 10 hours. So I could take out this X. This is called substitution, right? Actually, I'm going to keep that for a second. I'm telling you that X was 10. So I'm going to do, I'm going to substitute X in. I'm going to substitute 10 in for X, just like a football play or basketball or a substitute teacher coming in. The substitute comes in, takes the place of something else. The rest of the things doesn't change, right? The rest of the team doesn't change when you substitute one player in. The rest of the class doesn't change when a substitute teacher comes in, just that one thing, right? So I'm going to substitute in 10 for X, which means everything stays the same. Y stays there, equal sign stays there, 8 stays there. The only thing that changes is X. X comes out, and 10 goes in. Now this is weird. I can't just leave the 810 because it looks like 810. So I'm going to have to put a time sign in there because there was a time sign in there, remember, between the 8 and the X, it just was invisible. So I got to put a sign in there so it doesn't look like 810, right? But now I have Y equals 8 times 10. And now I can find out how much she made. She made 8 times $10. She made $80. So once I know one of my variables, I can very easily tell what the other number is. Okay? And usually, guys, we'll have an equation that says y equals something about x, because remember, y is the thing I'm interested in. Okay. Um, Let me actually go into this in a new video. The next video will be called about dependent and independent variables. We'll talk about why we usually have y equals and not x equals. Okay. So that's it for this video. Again, variables can represent two different things. First of all, something we don't know the value of, and second, something that changes, the value changes about it. And we've also seen that variables can relate to each other. We can have two variables that relate at the same time. So as I get older, my height increases. There's two things that change. I get older, my height goes up, and they're related to each other. Um, as I work more hours, I get paid more money. Two things that change and that are related to each other. Um, those are good examples. Yeah, we'll stick with it there. So next video, we'll talk about independent